A ton of amazing things are taking place in the world of AI today. Perhaps the most exciting of these things is the fact that the guys at DeepSeek have just revealed that they have figured out a novel way that allows models to teach themselves how to think better. This is huge because such capabilities have already given these new models to perform better than giants such as GPT-4all. Let's take a look at these innovations that are poised to change the way we see AI today. DeepSeek GRM. When we talk about this amazing AI that DeepSeek created to think for itself, we are talking about the DeepSeek GRM model. Thanks to SPCT, also known as self-principled critique training, this model is capable of handling single, paired, or multiple responses without breaking a sweat. This is because it is able to take the requests, produce its results, and assess them. As interesting as this assessment of its results are, users will find that what actually makes DeepSeek GRM stand out is that it can perform something known as repeated sampling at inference time. Simply put, this means that the model's internal judging process can be sampled several times so that the results can be reviewed. Sure, this may take up some more of the intended time, but it can help the user come up with more accurate results. To make sure the steps are safer and more secure, DeepSeek also introduced the meta-reward model. This acts like some sort of gatekeeper in the sense that it watches out for any weak or inaccurate critiques that the system may come up with when assessing the results. Such a highly capable AI model that is guaranteed to give the user access to the best results today. How does DeepSeek train DeepSeek GRM? To get the AI model to work so well, you'd find that the guys at DeepSeek trained it with what is known as self-principled critique tuning. This may sound familiar to you guys because we mentioned it just a few minutes ago. In order to handle multiple responses at the same time, like we mentioned earlier, we found that SPCT functioned in two phases. The first phase involves what is referred to as rejective fine-tuning. Also known as RTF, this phase is carried out in a bid to make sure that the model has an idea of what good critiques look like. To accomplish this, the model makes use of 1.07 million pieces of general instruction data, along with 186,000 items of rejectively sampled data. To show how great this model is, the guys at DeepSeek revealed that when they made use of a parameter model known as Gemma 227B, they made use of a batch size of about 1024 and a learning rate of 5e6. This allowed them to train the model with about 900 steps on 128 A0100 GPUs. This helped them achieve about 19.2 hours worth of work. Pretty impressive work, don't you think? Following this, the model embarks on the next phase. This phase is a rule-based online reinforcement learning phase that is referred to as GRPO. This creates a situation where the model's predicted best response is compared to the actual best response that comes out of the model. During such a process, the actual best response gets a reward of +1 if it matches, while giving a score of -1 if it doesn't. To make sure that things are even more efficient and accurate, they also make use of a KL penalty of 0.08. This helps the model make sure that it isn't drifting too far from its target. To achieve such a feat, this phase makes use of 237,000 data points and runs for 900 steps with a batch size of 512. It also runs 128 A100s for a period of about 15.6 hours. Eager to show off the versatility of this app, DeepSeek revealed that they had also tested different sizes of the generative reward model. This involves testing out sizes ranging from a 16B version that was built on a mixture of Expert's Foundation to a 27B version that was built on Gemma 227B. As if this wasn't impressive enough, it was even tested on a massive 236B version as well as a 671B version. Due to all this testing, it is believed that the default size that showcases the results seems to be the 27B version, as it seems to give the user the perfect mixture of performance and costs. That said, it is believed that if you try out rough repeated sampling at inference time, you will be able to get the 27B model to perform at a level that is quite similar to the single-pass performance to the 671B model. As you can imagine, this is huge because of the costs and the hardware involved. Benchmarks. The specs are great, but wait till you see how the model performs in the benchmarks. With special focus being put on factors such as chat, safety, and reasoning, you may be pleased to find that the model is also judged on its PPE, i.e., its preference and its correctness parts, as well as its R&B parts, in a bid to make sure that it performs well on its helpfulness and its harmlessness tasks. On the reward bench, we'll find that the 27B version of the AI model gets about 86% with a single greedy pass. As you guys can imagine, this is already quite high. See, imagine how excited everyone was when the model was tested with 8 sample voting. This improves the rating up to about 88.5%. The scores do vary going forward, but it has been revealed that if you do one pass and one pass only, you're likely to get a score of 69% on average. However, if you do 32 sample voting plus the meta RM, the score will be improved to 72.8%. To make things even more impressive, you'll find that these results have surpassed large public reward models, such as the Nematron 4 340B reward, which has a score of about 70.5%. It has even beaten GPT-4o's result of 71.3 when it comes to certain comparisons. As you can imagine, this system isn't perfect, especially when it comes to when only one answer exists. You'd find that this mostly occurs in fields such as math or coding, especially when there is no reference provided. However, if you find any ground truth solutions for it, it may actually be able to get scores that are as high as 90% if not more on maths. This is great because this puts it in a position to go toe-to-toe against specialized models. It is so impressive that it can generate detailed critiques. This is in stark contrast against models that just give single scores. Now, this can result in the model being slower while costing more to compute, especially if you sample multiple times to improve the accuracy of the model. There also seems to be something of a delicate balance in the KL penalty, as if it's set too low, it could lead to the misbehavior of the model. To add to the issues, ablation studies have revealed that principal generation and rejection sampling have proved to be crucial. As a result, getting rid of them could undermine the performance of the model. Despite this, users may find that this generative approach is flexible as it allows for everything from chat to safety. DeepSeek R2. Such features turn our attention to the R2, DeepSeek's up-and-coming chatbox of the future. As you can imagine, everyone is excited about the R2, especially with the success that was experienced with the DeepSeek R1. This is perhaps why everyone thinks DeepSeek will leverage GRM immediately if they will attempt to do something that's even more advanced than what we all have planned for them. Right now, we don't know much about R2's release date or if it will implement all the features that were described in the new paper, but this hasn't stopped the excitement that has been generated in respect of this new AI model. Maybe it's because DeepSeek is talking about open sourcing these advanced AI models, but at this point in time, nothing's for sure when it comes to what comes out of this model. With SPCT being the backbone of DeepSeek's self-improving model, the model can create its own rules, critique its answers, and give itself the feedback it needs to get better with every given moment. This is especially the case when its response matches what it considers to be a good answer, as this reinforces its good behavior. With any luck, it will learn faster and more accurately without needing to rebuild the whole thing while working on a wide range of facts. With such an AI model, DeepSeek may actually be setting the pace for the world of AI in the years to come.